This is the final exam for ECE 202. This is a closed book, closed notes exam. Before you do this exam, you should have completed all the videos for the course, up to and including the material for Chapter 16, page 32. If you haven't done this, don't look at the exam and go back and study that material. This exam has 8 questions. Let's go over the individual questions and you'll have 2 hours to do the exam. For problem number 1, given this RLC circuit with an input that's 8 times the cosine of 500t, can you find the voltage V of t in steady state? For problem number 2, can you find the waveform f of t from f of s by doing a partial fraction expansion? For question A, f of s is equal to 11 times the quantity s plus 3 divided by s and then times s plus 4. For the second function, it's s plus 7 divided by s squared plus 6s plus 25. For problem number 3, can you use Laplace transforms in a partial fraction expansion to find the voltage across the capacitor, V sub c of t? The next page has some additional workspace. Problem number 4, given the transfer function minus 10 times s plus 10 divided by s plus 1000, I'd like you to plot the magnitude in dB and the angle in degrees versus omega. Make your own log paper and plot the forms from our notes with a dashed line and the final plot with a solid line. I'd like you to label all slopes and all levels. In problem number 5, there are 2 proofs. The first one is, can you show that the Laplace transform of a times f1 of t plus b times f2 of t is equal to a times f1 of s plus b times f2 of s? For the second proof, assuming that part A is true, can you show that the algebraic sum of the S domain voltage rises equals the algebraic sum of the S domain voltage drops around any closed path? In other words, if the rises in voltage are V1 through Vj, that's equal to the drops, say Vk through V sub n. In problem number 6, I'm going to give you the definition of the Fourier series from chapter 13. It's listed below. Given the following waveform, f of t, which has a period of t0, can you find the b sub n of the Fourier series? Now you may or may not need the following identities: that the integral of x cosine of ax dx is equal to this, and that the integral of x sine of ax dx is equal to this. The following page has some additional workspace. For problem number 7, given the following circuit, which has a transformer using our dot notation, can you derive the value of V2 given the following specifications? That V1 is a voltage of 30 times the cosine of 200t, the load is an open circuit, L1 is 100 millihenries, L2 is 100 millihenries, and the mutual inductance is 35 millihenries. In problem number 8, given a set of wires and a load, and an input that's 240 volts RMS at angle 0 and at 60 Hertz, can you find the current I sub L in the load? Can you then find the voltage across the load? Then can you find the apparent power generated, S sub gen, in rectangular form, so real plus j imaginary? And lastly, can you find the power factor of the load? And this is the final exam for ECE 202. You can find this final exam in the ECE 202 ebook near the end of the ebook. Print this exam and you have 2 hours to do it.